Today, we will take a look into how can we use the quadratic formula to find solutions. So the main idea here is that when using the quadratic formula, we can encounter complex solutions or imaginary numbers. All right, so let's refresh a little bit from Algebra 1, and that is, what is the quadratic formula? So this is what you have seen before, and this is what we're going to call the quadratic formula here. We use this quadratic to solve, we use this formula to solve quadratics. That's why it's called a quadratic formula. So you will have some kind of a quadratic, and we're going to take a look into the coefficients, and that will be the coefficient in front of x squared, we're going to call that a. The coefficient in front of x, we're going to call that b, and the coefficient that is by itself, or the constant, is going to be called c. So when you have a quadratic equation that looks like that, we're just going to look at the quadratic, we're going to look at the coefficients, we're going to plug them into this formula, and this formula will always give you the solution for that function. All right, so let's take a look into this. So let's use the quadratic formula to solve the following, simplify your solutions. All right, cool. So first things first, you need to make sure that your equation it's equal to 0. All right, so if we take a look at here in example A, yes, my equation is equal to 0. So we're good. So your next step is to identify what is A, what is B, and what is C. So we know that A is the number in front of x squared. But in this case, it seems like there's no number, but there's always going to be an imaginary one. So in this case, A is 1. B, it's always going to be the number in front of x, which in this case is a whole -2. And C is the number that is by itself, which in this case is 10. Perfect. So we see that we have this quadratic equation. We know what A, what B, and what C is. We have an equation. Let's plug it in to solve this equation. So we're going to have that x is equal to negative, parenthesis, the value of b, but here b is -2. So plug that in, plus or minus, square root b squared, but we know that b is -2, so we're going to have -2 squared, minus 4, times a, but we know that a is 1, times c, but we know that c is 10. Cool. Everything divided by 2 times a, but we know that a is 1. All right. So this is your solution. This is the solution to this equation here. But obviously it doesn't look nice. So what do you do here? Well, we got to simplify our answer. So let's see. Still x is equal to, what I want you to do is just, instead of looking at a big expression, just look into a small expression. So let's concentrate in here. Negative times -2. Well, we know that a negative times a negative, that's positive. So right here, this is +2. Let me rewrite that too. So we got +2 plus or minus. Now, let's actually first find out what this number is. So -2 to the second. This is equals to +4, because -2 times -2, that's +4. So we have 4 minus 4 times 1, so this is 4, times 10, so that is 40. Everything divided by 2 times 1. Well, let me rewrite this line. All right, better. 2 times 1 is just 2. Perfect. Now let's see what we have inside the square root. So now that you can actually simplify this as 2 plus or minus the square root 4 minus 40, so this is -36, all over 2. All right, so what else there is to simplify? Well, let's continue our answers here. Well, notice here that we know that the square root of 36 is just 6, but we don't have 36, we have -36. But we know that when you take the square root of a negative, you can take it out as an I. So now this becomes x equal to 2 plus or minus I square root of 36 divided by 2. But we also know that we have 2 plus or minus square root of 36 is 6, so this is 6I. Now, here, you can say that this is your final answer, but you can also simplify the following. So this is a final answer. That's fine, but we can still simplify this a little bit further, because notice that this 2 is dividing both numbers, the 2 and the 6. If you want to think about it, you can rewrite this as the following: x equals to 2 divided by 2 plus or minus 6I divided by 2. Notice that this 2 is dividing both of them. So it's the same as if you say, well, let me divide them one at a time. So now this becomes 2 divided by 2. So this is just 1 plus or minus 6 divided by 2. So this is 3I. So this is my final answer. Let's actually do it in red. So this is my final answer. X equals 1 plus or minus 3I. And this is what we mean by solutions having complex numbers. Notice that here you have an I. So because you have an I, that means that there's an imaginary part in your answer. So this is why we can call this an imaginary number. This is the imaginary part. When you have an imaginary and a real part, that's what we're going to call a complex part. That's something that we have discussed on previous lessons here. Do we have another example? Yes, we do. So let's take a look at example B now. And again, notice that this is a quadratic and it has 3 terms. There's different methods that you can use to solve this, but right now we're taking a look into the quadratic equation. And to use the quadratic equation, first we need to make sure that the equation is equal to 0, which it is, so that's fine. Now the next step is to figure out what A, what B, and what C is. So let's figure that out right now. A is the number in front of x squared, which is just 2. B is the number in front of x, which again, it seems like there's nothing, but there's an imaginary 1. And C is the number that is by itself. So that's another 1. Let me bring down the equation so you can see here. All right, so I'm just gonna put the equation here so you can have it as a reference. So now let's just plug it in then. So now we're gonna have, now that we know what A, what B, and what C is, plug into the equation and simplify. So now we have that x is equals to negative B, but we know that B is 1, plus or minus B squared, but B is 1, so we're gonna have 1 squared, minus 4 times A, but we know that A is 2, times C, but we know that C is 1. Everything, the whole thing, divided by 2 times A, but we know that A is 2, so we're fine right here. So let's see, can we simplify this a little further? Well, let's check it out. So we have x equals negative times 1, so this is negative 1, plus or minus the square root 1 to the second, well, that's just 1. Now we're going to have negative 4 times 2, so this is negative 8, and negative 8 times 1, still negative 8. Everything divided by 2 times 2, which is just 4. All right, let's simplify this a little bit further. So we're going to have x equals negative 1 plus or minus square root of 1 minus 8, so this is negative 7. Everything divided by 4. Perfect. So can you, well, yes, can you say that this is your final answer? Well, not exactly, because notice right here that you have the square root of a negative number. So we know that this is going to be an imaginary number. So let's rewrite that. So x equals negative 1 plus or minus, now we're going to have I square root of 7 divided by 4. All right, so let's see. Can we simplify this just like we did with the previous example? Well, let's see. Negative 1, can you divide it by 4? Nah. Square root of 7. Can you simplify the square root of 7? 7 is not a perfect number, so you cannot take the square root of it. You cannot expand 7 in multiples of perfect squares, so this is fine. So we cannot simplify this expression just like we did with the previous example. So This is our final answer here. Now, for your entrance ticket, use the quadratic formula to solve the following and make sure you try to simplify your solution.